Hello my dear students, welcome to my YouTube channel, that's Concepts of Chemistry. Before starting today's lecture, please do subscribe my channel. My dear students, today we are going to derive the energy of electron in nth orbit according to the Bohr atomic model. In the previous lecture of Rutherford model, we have derived the potential energy of electron and the kinetic energy of electron. Let me revise that thing first. So I am writing according to the Rutherford model first. According to Rutherford model, we have derived potential energy of electron, that is potential energy is equal to the minus k z e square divided by small r, and we have also derived kinetic energy of electron. Kinetic energy of electron. So kinetic energy came out to be k z e square divided by 2r. So what are these terms? First of all, what's k? K is constant of permittivity of medium between nucleus and electron. What's Z over here? The Z is atomic number. Was small e is charge on electron, and what's r? It's radius of the orbit in which electron is revolving. So now my dear students, let's calculate the total energy of electron. So now I am evaluating the total energy. Total energy of electron in nth orbit. I am representing my total energy to be the capital E for the nth orbit. It comes out to be the obviously the sum of potential energy and kinetic energy. Now what is the potential energy? I have just written down the formula. It's minus k z e square divided by small r. And what's the kinetic energy? It's k z e square divided by 2r. Now the energy total comes out to be minus k z e square divided by small r. So that's the total energy of electron in the nth orbit. Now in the previous lecture of Bohr atomic model, we have evaluated the radius of nth orbit to be equal to n square h square divided by 4 pi square m z e square k. So now let's substitute the value of radius. Now I'm substituting this value of radius over here. Here's a little mistake. It comes out to be 2r, sorry. Now I'm substituting the value of radius over there. So this thing comes out to be energy in nth orbit. It comes out to be minus k z e square divided by 2. Now the radius comes out to be n square h square divided by 4 pi square m z e square k. Now let's evaluate it further. The energy of nth orbit comes out to be minus k z e square into 4 pi square m z e square k divided by 2 n square h square. Now here this 2 will cut out to this 2 to the 4, 2 to the 4, and rest nothing is cancelling out over here. So the total formula comes out to be the energy of electron in nth orbit comes out to be minus 2 pi square m z square e to the power 4 and the k square divided by n square and the h square. Now in this formula you can easily observe that except this z and n, except z and n, all the values are constant. That's 2 pi m e k h, they all are constant value. So I'm again mentioning the formula. So energy in nth orbit comes out to be minus z square n square, it comes out to be 2 pi square m e to the power 4 k square divided by h square. So it signifies that energy of nth orbit is directly proportional to the minus z square divided by n square, or energy of nth orbit directly proportional to the n square divided by z square. What is n? N is the orbit number. As the orbit number increases, the electron gets farther away from the nucleus and its energy increase. On the other hand, if the z, the atomic number, increase, the number of protons in nucleus increase, the attractive forces between the nucleus and electron will increase, thereby decreasing the total energy of the electron. Now I'm substituting the values of all the constants over here. So energy of nth orbit comes out to be minus z square divided by n square. Now 2, what's the value of pi? It's 3.1414 square. What's the value of m? M is the mass of electron. It's 9.1 into 10 to the power minus 31. What's the value of E? It's 1.6 into 10 to the power minus 19 raised to the power 4. What's the value of K? It's 9 into 10 raised to the power 9 square. Now let's come to the denominator. What's the value of h? Is 6.626 into 10 raised to the power minus 34 square. From all this data, you will finally come to the formula, that's energy of electron in nth orbit comes out to be minus 2.18 into 10 raised to the power minus 18 z square divided by n square. So that's the energy of electron in nth orbit, and the unit, the most important point here, the unit for this formula is joules per atom, because we are talking about a single atom. Now let's convert this unit joules per atom to electron volts per atom. I know that my 1 joule is equal to the 6.24 into 10 raised to the power 18 electron volts. So what I will do, energy of electron in nth orbit comes out to be minus 2.18 into 10 raised to the power minus 18 into 6.24 into 10 raised to the power plus 18 into z square divided by n square. So the energy of electron in nth orbit comes out to be minus 13.6 into z square divided by n square, where z is atomic number, n is orbit number, and this unit comes out to be electron volts per atom. Now let's convert the joules per atom to joules per mole. Now I'm converting joules per atom to joules per mole, and we know that 1 mole of any substance has 6.022 into 10 to the power 23 units or atoms. So what I will do then, energy of electron in nth orbit, it is minus 2.18 into 10 to the power minus 18 into 6.022 into 10 to the power 23, that's Avogadro number, into z square divided by n square. So this evaluation comes out to be, the energy of electron in nth orbit comes out to be 1314 negative into z square by n square, and this will be in kilojoules per mole. So that is, we are having three different formulas of energy with different units. The first one is energy of electron in nth orbit is minus 2.18 into 10 to the power minus 18 into z square by n square joules per atom. Then energy of electron in nth orbit is minus 13.6 z square by n square electron volts. And then finally, the energy of electron in nth orbit comes out to be minus 1314 into z square by n square kilojoules per mole. So that's all for today. I hope you understood today's derivation. It was a very easy one. You have to just remember the final formulas so that you can easily attempt your numericals. So I hope you all understood today's lecture. If any student wants to book a paid one-to-one online class to clear their doubts, then she can contact me. My phone number is mentioned on thumbnail of this lecture. Please like, subscribe and share my channel to maximum number of students. Don't forget to press the subscribe button. Stay blessed.